In this video, we will see dry run of the code. Now let's quickly do the dry run of our approach. So let's quickly do it. So let me take n equals to 5. Okay. What will be the binary representation of 5? That will be 0, 0, 1, 0, 1 with base 2. Okay. Now how we can solve with by our approach? I will take one count variable that is starting with 0, 0. While n is greater than 0, so yes, n5 is greater than 0. I will come here and I will say if I will execute this one. So if n and 1. So basically, when I'm writing one single end, my program, my computer will get to know that now n is with bit operator, bitwise operator. Remember, we have used n as a bitwise operator. So now this the program will treat n as a bit binary digit, not as a number like 5, not as a decimal number. So what it will do, it will say 0, 0, 1, 0. Let me use white pen. So it will say 0, 0, 1, 0, 1, right? And it will take an AND operation with 1. And what will be the result? So basically, the result will be 1 and all these 0. So the result will be 1 and that is not equals to 0. So my count will be updated to 1. Right, and I will come to here, n will be n right shift operator. So now my this n, right, this will change to basically when I apply right shift operator, right, this one will be eliminated and it will change to this 0, 0, 1. Right, again I will check, is n is greater than 0? So yes, n is still greater than 0. What is the value of this n? Here the value was 5. Here for this value, that is I guess 1. Yes, the value is still 1. What I will do, I will again do, I will again come to if condition and I will use end 1. Remember all these things. Whenever I am using single end, right, because this is an bitwise operator, my computer will get to know that it would treat n as a binary digits. So again, it will treat as n as a binary digit. So it will treat 0, 0, 1 and it will take and 1. So what will the result? It will be 0, 0 and 1. So again, I am getting 1. What I will do, I will update the count. Count will be 2. Okay. Sorry. I have just changed it, right? It will, when I'm doing this slash, it will be 0, not 1. So let me remove this one, right? It will be 0, 0, 0, 1, 0, right? Yes. And now what will be the decimal number of this one? The decimal number will be 2. Okay. And again, what I will do, I will apply AND operator. So it will be 0, 0, 0, 1. Right. What will be my result? It will be 0. It will be 0. It will be 0. It will be 0. So now this condition is not true. All the results are 0. So my count will not be 2. It will be 1 only. Right. It will remain to 1. Okay. Then what I will do, I will move ahead. Right. And I will again apply the right shift operator. So if I am applying right shift operator, right, it will change to this one. Basically, it will change to 0, 0, 1. What is the value of this decimal value of 0, 0, 1? That is 1. Okay. Again, I will apply the bit operation. So it will be 0, 0, 1. If I apply it, I will get 1, 0, 0. Right. So that is again, I am getting 1. What I will do, I will update the count to 2. Right, and again I will apply the right shift operator. So if I'm again applying the right shift operator, what I will get as an n, I will get n as a 0. Right, now this is 0, this is completely 0. I can directly say yes, n is now not greater than 0. So simply stop. And what is my count is 2. So that will be my answer, and my answer will be 2. So you can see from 5 we have reached to 2, from 2 to 1, and from 1 to 0. That is not the n iterations. These are log n iterations. So that's why the time complexity will be big O of log n and space complexity will be big O of 1. So that's all about this problem. See you in the next problem. Okay. Thank you and have a nice day.